You hear me? Yeah? Yeah. Oh, sick. Cool. Well, hey, everyone. Obviously, as you know, my name's Alex. I run a company called Tanda. We do payroll automation, which is like not the most exciting topic in the world, but obviously everyone here probably has a job or has had a job at some point in their life, and you probably liked getting paid. That's definitely the highlight for me. We make sure people get paid right and on time and in a way that doesn't cause the employee to go to jail. So it's a pretty important thing in the scheme of things. That's not what I'm going to talk about. I'm going to talk about Lego. It's probably more fun again. Trying to get some, I guess, cred by talking about cool things. But also talking about business software. So if business software is the sort of thing that's been, obviously software has been around for a long time, and originally, back when computers were young and back when Apple was first making their sort of desktop computers, people made computers with the intention of selling them to businesses and having efficiency software being used as the main use of it. So the first bit of, I guess, software as we know it was a spreadsheet program, VisiCalc. And for a long time, software for businesses and for enterprise and for corporate people has been pretty hard to use and pretty clunky and just generally horrendous. Over the in recent times, things have been getting better. People are putting a lot more effort into actually making software that's easy to use, easy to understand, and easy to work with, which kind of creates some unique challenges that we haven't really thought of, we weren't thinking about 10 years ago. And I'm going to be talking about some of the ones that we've come across in our work and some stuff that we've seen from other software that's popular these days. So everyone here has probably used Slack or heard of Slack or used IRC. Slack's like IRC, but with better CSS. I saw someone doing a fist bump. Get with the times. We use HipChat, so we're just as uncool as you. But Slack have it easy, right? Because they've taken something that has existed for a long time, which is IRC, and they've added a nicer style sheet to it, and they've added some tools like file uploading and things like that that didn't really exist before. But they haven't fundamentally changed how it works, and they haven't dealt with a really complex field, I think. There are certainly other classes of software that are just as important, if not more important, that are still really hard to get right. And I'll be talking about how some of those have benefited from the ideas of Lego. I don't need to use Lego to anyone, I hope. So, this is Lotus Notes. This was Lotus Notes. Old mate from IBM here recognizes it because his company owns this. Which, yeah, I wouldn't be proud of that either. But I worked for IBM for a while. I had to use this every day. It is fucking horrendous. And the reason it's bad, right, is because see all those buttons across the top? Every little bit of functionality that you can do in Lotus Notes is a button there. They've basically taken this one screen, which is your email inbox, and thrown everything you can possibly do into one place. Now, the good thing about that is you know everything that you can do with the system. The bad thing is it's kind of hard to actually do anything because you have to be like, I'm just going to click the box with an arrow pointing upwards on an angle. I'm not sure what that means. I'm guessing it means going to another message. It's very confusing and very hard to use. This is Gmail, which I'm guessing most of you probably use. This is a better way of doing the same thing, right? Now, the biggest difference between the Lotus Notes screenshot and Gmail is Gmail has more features, more functionality, works better, is faster, is easier to use. But you can't, but you can't see most of them. There's not as many buttons across the top. There's much less functionality that's actually directly visible to you because a lot of the actual way stuff works is abstracted, and a lot of the abstraction's been done through what Gmail calls labels and filters. I won't go too much into how those things actually work. The point is that they've actually taken some stuff that can be automated and can be made to be simpler and hidden in a way that still makes a lot of sense. They've also added the search box, which you can use to search for any kind of item ever, which again takes away probably 10 different bits of functionality that actually did the same thing in Lotus. This is not how you should use Gmail because it's got speech bubbles on it, but this is, I guess, supporting out of some of the more powerful tools in there. So, for example, the circles on the left from when Google Plus existed, and the labels further down on the left. All those sorts of things there. Now, in Lotus Notes, or in any other email software, you have folders. You get an email, you put it into a folder. The point is that these things were designed from the start to be done automatically. It's really quite annoying adding an email to a label by hand. It's much easier to set up a filter for it or a way of doing it programmatically. So Gmail had this idea, basically, of making it much easier for power users or people who like to tinker with this sort of stuff to go and really get really involved in the processing of their email and make it something that people actually get obsessed with. And some people get really obsessed with using Gmail as a result. Whereas people who use older classes of this sort of software spend half their life putting an email into a folder, which isn't really that exciting. So that's Lego. I really like Lego. I grew up playing with it. The reason I like Lego is because you make anything you want, and you aren't really limited by, I guess, an instruction booklet. So you obviously get some blocks, you get a list of things that you can make with it, and here's some instructions on how to make them, but then no one ever gave you a booklet that shows you how to make that. That's just too profound for any sort of Lego instruction guide. And you can make spaceships. So if anyone hasn't seen the Lego movie, you should definitely see the Lego movie. It's like the best movie ever. Back off Lego. This is an example of some payroll software. Again, same thing as I said before with email software of the past. Every bit of functionality you can think of is in the list across the top there. But 95% of the time, you don't care about most of those things. You just care about what you're doing right now, which in this case is updating Mary Ortiz's phone number, whatever it is that you're doing. So it really just tries to throw every possible option to you at one time. Makes it very hard to actually get anything done. This is some payroll software figuring out how much someone should get paid. So they've got in the top bit the times that they worked. In the bottom bit, it's trying to figure out that they're getting paid holiday rates and ordinary rates and overtime rates. It's kind of hard to actually infer that from looking at it, though. If you look at that, you just see a bunch of numbers and a bunch of times and a bunch of... This is some more software that's doing the same thing. All this enterprise software just has this huge fixation with tables and just having things in gray and white and just lumping stuff into one place and letting the user actually figure out where the information is, what information is useful from there. And that's something that I've noticed a lot, and that has been happening a lot. The result is that despite everything being structured in a table, it's actually really hard to get anything useful out of this information because it's just sort of all being thrown at you and being rammed down your throat. As a user, you're like, well, I'm not sure what's actually useful here. I guess I'll just try and memorize all of it. So, small detour into what we do. This is basically, on this screen, the same information as on that screen. All we've done is draw a graph of it. Now, what's interesting there is that we've actually gone and presented this information the way it actually makes sense to be displayed for someone. So if you're thinking about, I worked these hours and I get paid at different rates for these times, what actually is important is showing that in a timeline sort of format, because it is a timeline. Rather than displaying everything in a table and having different columns that don't have any relationship to each other side by side, displaying things in a color-coded timeline with color coding that relates to dollar figures makes a lot more sense conceptually. It makes it easier for people to understand. That's one software example. There won't be any more. This is an example of some other software also used for paying people. This is what it's like. This is the process of configuring it. Now, this one actually looks quite good. It's not particularly clunky or slow to use or hard to use. The problem with it is it's really, really slow. So these guys, who I won't name, were facing a lot of competition from cloud software that runs in a browser, and their solution was to make their desktop software cloud-enabled. So what happens is every time you click on a button, so say you clicked on the OK button or the cancel button, or clicked on a different tab within that view that's currently open, it makes a request to a server somewhere in the States and then waits for a response. Now, when you're using desktop software, you don't really expect that. When you're using Microsoft Word, if you clicked on like the tools menu and you waited for a server response to come back before the menu loaded, you get pretty pissed off. That's what using this sort of stuff kind of feels like, which is, again, pretty horrendous sort of experience. There's a lot of this is the worst experience I've seen, though, out of all this sort of old-school enterprise software that we deal with. This is, if you're a power user and you don't want to go and click on menus and wait for server responses every now and then, you can just fill out this handy configuration file. The first row is column headers. Like you can probably see it word wraps twice. So there's 3 lines worth of column headers. And the rest is just simple data that you can easily enter in. It's really annoying dealing with this stuff. And a lot of people actually spend half their lives typing these files out and just working with this sort of clunky stuff. Now, I'll skip this slide for a second. What I've found pretty interesting, what we've learned at Tanda and what we've seen from other people doing similar sort of stuff, is you really can make software that does a lot of complicated stuff a lot easier to use by thinking about it in terms of how you can make it more easy for the user to configure it. So rather than making your user go through this sort of thing, or making your user wait 30 seconds to actually get into another menu because they need to wait for a server response every time they click a button, you can make stuff that's a lot simpler to use. Gmail has a good example, as I said before. If you use an old-school email program, you have to be dragging stuff into a folder every time you get a new email. Gmail will like, well, fuck that. We'll do that for you. So every email, you can set up rules to have it labeled and filtered automatically in a much simpler fashion. Gmail added search, which again does the same thing. It sort of searches it by subject line or body or email or whatever you're interested in. And it's sort of the cornerstone of how the system works. So again, that causes people to get really obsessed with using it because it's specifically designed for power users who like to configure their stuff and tinker with their stuff, but don't want to sort of suffer with actually using really clunky, hard-to-use interfaces that are still really annoying. So what we did was we wanted to make something that was as powerful as this, but didn't look like that. This is basically the same information, but sort of spelled out in English rather than in text file. We make sort of small building blocks they use to define how someone should get paid. So this is one building block. This is 3 building blocks, and you sort of piece them all together, and you come up with this jigsaw of things that all sort of fall into place. And you have all these building blocks you piece together, and you tell a system how someone should get paid. This is really good because it makes a system that's instantly really highly scalable. If I want to pay someone in a million different configurations, I don't need to pre-code all these different configurations myself. A user can just simply go and configure their own stuff. I wanted to show an example of one of our competitors who has 1,000-line XML files for each of the different configurations that they support. And there's 3 of them because that's all they support. But I couldn't find one because we're not meant to have those because they're competitive. So unfortunately, I couldn't track that one down. But it is an example of what I guess, the alternative of what you can be dealing with. The reason I talked about Lego before was when I explain this stuff to people, I talk about in terms of we built these building blocks that are kind of like Lego, and as a user, you sort of piece them all together, and you can arrive at the chart at the bottom. Now, this idea of using Lego-style metaphors for stuff isn't one I just thought of moments earlier. There is a company or a product called Zapier that does something actually really similar. So they took the idea to the next level, and they were like, well, people really like using systems that they can configure and sort of piece together in interesting ways that the creators didn't think of. What could be more interesting than piecing totally unrelated systems together? So all Zapier does is it pieces unrelated software, for example, GitHub and Trello, and lets you sort of take one action from one into another. What I thought was really cool about that, though, was obviously when you buy Lego, you also get this playbook, which has like a list of different kinds of things you can make with your Lego set. Zapier have their equivalent, which is called the Zap book, which is literally just lists of different ways that you can piece different kinds of software together. So it's quite cool because if you were the person who made GitHub or the person who made Trello, you never particularly thought of these sort of tools working together in a certain sort of way. It's just the sort of thing that can be pieced together organically, I guess. So why does this sort of stuff matter? This is Mike and Scott. They started a company called Atlassian about 13 years ago. They're going public in the States sometime this year at a valuation of about $3 billion. So it's $3 billion US. So they're pretty big. Their flagship product is a bug tracking tool called Jira. This is what part of Jira looks like. What Jira did that was really, really smart that no one else thought of at the time, and still no one else really does as well, is that you can absolutely customize every aspect of it completely, and in a way that's still not totally terrible to use. So all these fields here are sort of things that you can make as custom fields, and then you can have custom values within them. And the whole thing is specifically designed around a really micromanaging sort of project manager going in there and customizing the heck out of all of it. So if I'm particularly anal about what language a particular bug, or what operating system a particular bug occurs on, I can create 10 different fields for the operating system. And Jira won't stop me. And it has a set of best practices. It kind of recommends what you should be doing. But if you want to go and make it really different, really interesting and unique for your particular use case, it sort of encourages that behavior. Now, when Atlassian started 13 odd years ago, most bug tracking software did not look like that. It was much clunkier, much harder to use, and still also much less flexible. It was much more rigid in terms of here's how you have to do stuff. So they really made it quite different and made it in a way that both managers liked to use because they got obsessed with customizing this stuff and reporting on it, and in a way that programmers still actually tolerated using because it still worked nicely and wasn't too oppressive. So the Atlassian guys did pretty well based on that idea, and obviously doing quite well now. So yeah, so we found, certainly in our work and what we've been doing, and also just in looking at the wider enterprise sort of software landscape at the moment, there's a lot of examples of people who are just getting really, really addicted to this sort of software that you can tinker with and customize a bit. And we found that particularly interesting because it's the same way that people get really addicted to Lego and then just make like cars out of Lego. That car drives. which is kind of weird. I don't really understand how. But we kind of thought that if you can get people excited about using your software and excited to go in there every day, 10 times a day, and tinker with how it works and try and configure new stuff and get new results out of it, that makes stuff that's really sticky and people get really excited about using. Again, just like said car. And obviously I couldn't go a whole talk about Lego without mentioning Minecraft. Even though it's not really business software, this guy made this ridiculous thing, which is basically just Lego on a computer, obviously in a much more scalable sort of way, and made a huge amount of money off it and made something that's extremely popular and sort of a cultural phenomenon now. So that is my quickly last-minute thrown-together talk. What I wanted to sort of mostly touch on was the idea that there is a lot of money, a lot of fun to be had in making software for what I guess is what is conventionally boring, old, crappy enterprise software. When we try to do something basically along those lines. And a good way to do it is what we found is to sort of focus on making stuff that people actually really enjoy using. And the way that people, or power users anyway, enjoy using stuff is they get really obsessed with it, really addicted to it, and they can really sort of tinker it and play around with it and make it more customizable. And Lego is a pretty good analogy for that, because the same reason you play with Lego is that you can make anything you want with it, only limited by the ideas that you have. So that I thought was particularly cool.
Do we have any questions? And while we're doing questions, we might get, I think it's Isabel. You hear Isabel? We'll get you up to mic you up while we've got questions. But feel free to fire away questions. One up back there?
Yeah. Yeah. So we manually enter that in. As I said before, we sort of let people build these sort of rules and configurations of their own. Obviously, it's based on the standard, so we'll have like a default of how you probably should pay someone based on what your industry you're in or whatever that is. And then you can go and sort of pick and change and configure these rules however you like. At the pre-built ones, yeah. Australia is particularly highly regulated in this space, more so than most other countries in the world. We invented the minimum wage. So we do have a much more focus on that. But there are certainly, like every part of the world has to pay people in different and highly confusing ways. So we'll get there.
So I've sort of tried to do pluggable blocks of things, mostly in software testing.
Mm-hmm.
I've always found that I could never quite be able to get the interface quite standard, and everything wants to be a little special block that isn't quite compatible.
Mm.
How do you manage the sort of tendency for everything to specialize and not want to be standardized and using tools?
So the question was, how do you sort of manage when you're trying to make something that's modular and generic, there's always going to be a special block that is particularly important and has to behave its own way? And it's a good question. What I've found is, so what I was originally going to talk about, and I sort of diverted a bit from it, was more around domain-specific languages and the idea of building a language sort of within your framework, within your code base, to speak the language of your problem. So the answer kind of falls into that of, usually you just end up accepting the special cases and sort of, I guess, almost celebrating them. So in my opinion, if something is particularly special in this modular block, so for example, in our particular case, there's special rules about how you should get paid overtime if you have been called back into work after the end of your day is finished. And it's just totally different to anything else that should normally get paid. So if your boss calls you back in when you finish for the day, the way you get paid normally just gets thrown out the window. And that's a special case, and it's kind of hard to have a really modular, generic system that figures that stuff out. Sometimes you just need to tell it. In this particular edge case that comes up, take all your other logic that you've got and put it aside and sort of think of things in this different way. I think the way you do that really depends on the domain that you're working in. But I don't think it's a bad thing to be thinking about, there's special cases and special blocks, so to speak. Because sometimes it's a good thing. It means what you're doing is interesting. There is a text representation. Well, that's what's stored in a database. So we store our stuff. You mean the rules, so to speak? Yeah. So we use. Who's familiar with Postgres, the database? So we use Postgres as our database, and then we use a data type called HStore. which is a hash storage. So basically, it's a key value mapping. So it's like a MongoDB, but inside a Postgres database. And the reason that that's particularly useful is because the sort of stuff we do, there's like 50 to 100 different fields that can influence how a particular piece of time is calculated. HStore is good because you can sort of categorize these fields broadly and then add new columns on the fly as you need to and sort of add new criteria when it comes up. So we'll have like a set of rules relating to the rate someone gets paid at and a set of rules relating to the times of day they could occur at and so forth. And then within that, there'll be like 10 different columns, which are HStore keys. So there probably is a text representation as well, but it usually lives directly in a database in this sort of hash key value storage style thing. I'm not sure if that answers your question. No, language is probably not the right word. That's why I didn't use it. It's a domain-specific representation of generic data and trying to solve a specific algorithm using it. All right, well, I'll be sticking around and we'll see you in the next talk if anyone's got any questions afterwards.